Question 7. Oh, I really love these questions, and 3 marks. Fantastic. Absolutely fantastic. What we'll do is I'll draw. Will I draw below? I think. Yeah. I'll draw it to the. No, I'll try and draw below. I'll draw below because it does make it a little bit more sensible, I think. So the differential graphs. Oops. Differential graphs. The first thing you want to do is just think about what your gradients are. Are they positive or are they negative? That's the first thing. So I'll just write it next to it, remembering that this is a positive gradient and this is a negative gradient. If it shows up, there we go. Okay. So this is negative, 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 yep, all the way to a turning point where the gradient is 0. And then positive, 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 we're going up the way. Oh, then interestingly, it's 0, then we're back to positive again. Okay, usually it's a turning point, so that's a point of inflection, but a bit rarer. So the first thing I'd point out is that where gradient is 0, when I do my differential, this isn't really y, this is dy by dx. So where is dy by dx 0? It's 0 on this line, isn't it? Dy by dx is 1, 2, 3, so there's no 0 line. So if I was to draw down the turning points become the roots of the differential equation. Once you know that, it's actually not too bad a question. Okay, so you get 3 and negative 1. And I'll just keep that line going down. Okay, so I then want to say what's positive and what's negative. So I'll get my highlighter out and I'll say, well, first bit up to this point here, it was negative. So up until this first turning point, my graph has to be in this quadrant because this is below the 0, it's all negative, yeah. After that, it's positive and then positive again. So after here, the graph has to be in here and then in here. So usually it goes kind of positive, negative, positive. So it would do something like this. Ours is going a wee bit funkier. So I know I'm going to have to go through these points. So doing something like that. So for my graph to get to here, it's going to have another turning point, isn't it? So I'll have to come down here, and then after that point, away it goes. Now that's actually very interesting. Usually we've got a cubic that gives us a power 2, a quadratic. This might be a power 4, and this is given as a cubic because we've got 2 turning points here. And interestingly, you'll see there, we've got the turning point on the x-axis, which shows us we've got a point of inflection. Okay, so that's an interesting point to note. So if you're trying to take something else away from this, look at the relationship there between the inflection and the turning point on your axes. Okay, so just take your time, get your roots, and then just follow the line. Usually it's, you get a parabola where it would go up and down because this might be a power 3, but this is a more complicated function, so we've got 2 turning points. Okay, so I think a few people might have been like, oh, wait a minute, how do I go from this quadrant to this quadrant via here, where you just turn direction. So, yeah. But yeah, 3 marks for that. Lovely little question. Hope that's helpful.